later and show caption. See? Save that. And let me now share the screen and we'll see about getting this out. Modules here. And we're looking at the second week, the third week actually. Wow. 2.3 homework.
Yep.
You said number 2 and
Number 2 and 3.
So let me download this so we can actually read it well. Downloaded it, not quite, almost. All right, I think you should be able to see it on the screen.
Yes,
right?
I can see it.
The data show the percentages of the types of energy consumed in the United States. Draw a pie graph for the data. What percentage of the energy used is from fossil fuel, coal, gas, and petroleum? Okay, so what's giving you trouble about drawing the pie chart?
The only thing that's giving me trouble is the percent part. I'm getting confused. Is that the actual percent that we have to put down, or is that just the frequency and then I get the percent?
No, the pie graphs don't have frequencies. They have portions of the whole circle.
I know.
Okay, continue. I'm sorry.
I know, like number 1, I was able to do it because
Right.
what we did, you know how for we have to get the degree, right? And so we would divide 360 degrees by whatever the sum of the frequency was. That's why
Right.
that's why I got confused, because it says percent
Okay.
of the energy on there. And
Gotcha.
I'm confused. Is that the actual percentage that we're supposed to go with, or is that the frequency and then we get the percentage?
No, it's the percentage of the whole amount.
Okay.
So 25% of the entire portion is see, some of these overlap, remember? So sometimes people get, that's why they add up to more than 100.
Yeah.
Some of these percentages, so 25% of people get their energy from natural gas, 21% get their energy from coal, and so forth. Okay.
Yeah.
But if you know the percentage, you actually just answered your own question without realizing it, because you know that you're coming out of 360, right?
Yeah.
So if, for example, you say that you have 25% natural gas, right?
Yes.
Want to figure out how many degrees that is. You know that there's 360 degrees in a full circle, right?
Right.
So because you're given the percent, you don't have to do that division step because you already know what the percent is. So you just take 25%, change it to a decimal, multiply by 360, and that should give you 1/4 of 360, which is 90 degrees.
Oh, so if we already have the percent, we don't need to do the division by the sum and whatnot.
Right, because you already know what the reason you're doing the division is to get the percent, so that you can then multiply by 360 and convert it to degrees.
Okay, yeah, because what we did, we would get the percent first, and then moving on to degrees, we would divide 360 by the sum of the frequency, and then we would divide
Almost
360 by by the sum of the frequency, and then we would multiply by whatever frequency numbers in that column, and then we
Yeah,
would,
so what you're saying, for the sake of watching this later, what you're saying is if you have frequencies instead,
yeah.
like number 1, the first thing you're going to do is add all of the frequencies together,
Mm-hmm.
get the total of that. Then to get the percentage of the pie for each class, you're going to take the class frequency, if I can spell correctly, the class frequency, divide it by the total.
Mm-hmm.
Then, okay, so that's going to give you a percent.
Yeah.
Okay. Then you're going to take that percent and multiply by 360 to get the number of degrees.
Mm-hmm.
Now you can combine the calculation here and just take the, you can take this quotient in this step where I wrote class frequency over total. You can take that number and multiply it by 360. That's why it worked.
Oh, okay. So I could, whatever I got from dividing class frequency by the total sum, I could, after I get the percentage, I could just like multiply it by 360.
To get the number of degrees. Yeah.
Okay, because I know we were supposed to, in class, we were taught the method to divide 360 by the sum of the frequency and then multiply it by whatever frequency number is in the column we're doing the equation in.
The equation comes out the same.
Oh, okay.
If you, it's a different way of handling. You can, but that same thing will work.
Okay.
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 Do you need any more help with
The
with number 2?
the next one, the only one other I need help on is number 3.
Okay, let's take a look at it. Jason, did you need help on this as well?
Oh, I was actually gonna ask you, reflecting on a question from yesterday.
Okay, all right. Give me just a couple of minutes. You're welcome to hang out and watch.
Okay.
Let me just finish with what you did. Havana, right?
Yes, Havana.
Havana, okay. So it says the popular car colors are shown, construct a pie graph for the, okay, these are all percentages
Okay.
because he put 19% here. So again, 19% are white. So 19% of 360 degrees is going to represent the white circle.
Okay.
Okay. I don't know, she added it a couple of days ago. So if you hadn't seen it on the homepage, she did add a video about how to construct pie charts.
Mhm.
It wasn't there when this lesson was first posted. So if you want to go back and check that out, it's under the lesson for this lesson, but there is a video on that as well. So
Okay, where's the video located again?
I will show you if I can stop sharing. Let me, I'm gonna have to open a window here. It's just something that I wanted you guys to be aware of because it was a new post and it's easy to miss it because it was just posted. Let me find it under models here. She added it in. I think she said somebody asked her about it. She also added one for the different data descriptions also. So let me see here. I'm just bringing up the. So if you look, let me share the screen. That would help. So you're not reading my mind, right? All right, so here we have, here's your, so you go to modules on the side.
Mhm.
This is in the lesson portion of the homework. So you have other types of graphs,
Mhm.
and underneath that, there are drawing pie charts, stem and leaf plots, and another one for back-to-back stem and leaf.
Oh, okay.
Okay, so these are optional to watch, but they're supplemental material for
Okay.
you if you're having. Okay.
Okay.
Anything else?
No, that's it.
No. You're
Yeah,
welcome
that
to.
was good.
You're
Yeah.
welcome to stick around and work with us, or go out and come back. I'll be here for an hour tonight.
Okay.
Okay.
Okay. I'll just stick around in case I have anything else.
Yeah, that's fine. Jason, how can I help you tonight?
Okay, so just looking, I have a problem for question 1. Oh, no, question 2 for 2.2.
Oh, question 2. Okay.
Yes.
That I do have downloaded. So let me stop sharing this and grab my downloads for 2.2. Are you able to use the calculator? Okay.
Still working. If anything, I'm just gonna, I emailed the math tutoring about renting the proper calculator for this class.
Got it. I did send you some videos. I don't know if you saw them. I sent them earlier this afternoon
Mm-hmm.
for your Casio. So okay, so we're gonna go to, where am I at? Downloads. Why is it so hard for me to find the downloads folder? Okay, here it is, 2.2 homework. All righty, you said number 2, right?
Mm-hmm.
Oh, this one, I remember this one. So yeah, this one takes a minute to put in. So we start with the highest and the lowest. Yeah, this is the one that you and I didn't have a chance to finish, right? Okay, so
Well, actually, that was question 1, but luckily I got some help from my brother-in-law on that
okay.
one.
So are you okay with, okay, so when you're doing raw data here, okay, we start with, you said 2.2 or 2.3? Because this is
2.2.
2.2, okay. So this, we start the same way that we would with any, we don't have a frequency distribution. So before we can do any of that work, we have to do that first. We have to get the frequency distribution first, okay?
Mm-hmm.
So that means that we're gonna have to enter the data into our calculator and do some manipulation to it. The lowest value we have is 3, as I recall, right? Minimum. Am I not? Okay, let me share the screen. I thought I was sharing the screen, but I wasn't. Let me make sure that I am sharing it.
Oh, yeah,
Okay.
it's 3.
Yeah, I believe the minimum is 3 here, right?
Mm-hmm.
And the maximum is 254. Is that what we said? I believe so. Max is 254.
Mm-hmm.
All right. So the first thing we want to do is get our class width. Okay. We know that we're using 6 classes. So, because the problem tells us that we are 6 classes. And so when we did the width, we had, let me put it up here. So the first thing we have to do, this is kind of set up before we can even do the problem itself. But this is, let me write a note here. This is problem 2, section 2.3, 2.2, right?
Mm-hmm.
So we know that our minimum was 3. Our maximum was 254. And we know that our width then, oh, and we're using our classes is 6 classes. So our classes are 6, right? So then we're gonna look and we're gonna say, okay, the width here is going to be 254 minus 3 over 6. Okay. So what do you get when you do that calculation?
Let me get my calculator. So 254 minus 3 divided by 6.
Mhm.
It's 251, but divided by 6, it's 441.88883.
Okay. So we decided that this is 41.883, and we decided we wanted the width to be odd, so we rounded this to, we're going to use a width of 43 units, right?
Oh, it's actually 41.833.
8, okay. I'll change that. That look better?
So it's 43?
Yeah, because remember we want it to be odd. And we would have to round this to 42, but we don't want to use an even number,
Oh, so
right?
it is.
So we're going to use a width of 43 units. Now we're going to construct our distribution for this. Now I would, in our columns, we're going to need, even though different graphs call for different types of data, I would suggest making one table with all the columns that you needed. So you're going to have class limits, right?
Oh,
You're going to
yes.
have class boundaries. We're going to have a frequency, and we're going to have to get the frequency by hand. And that's going to be the most
Tricky part.
time-consuming part of this. So we have class limits, class boundaries, frequency, midpoints, because we're going to need that for the frequency polygon, and then the cumulative frequency, right? So something like this, all right? So we have, let me put some column heads up here. So this is going to be class limits. Class boundaries. I'll put it over here, but I'll also raise it up. There we go. Class boundaries. Then we're going to have a frequency. which we're gonna have to tally. And we're gonna have midpoint. And we're gonna have cumulative frequency. So let's get our limits here. So this is going to be, we start with 3, right? And our width is 43. So this is going to be 46. We're going to add 43 to that. We're going to get 89. We're going to add 43 to that. We're going to get, let's see, 12, 132. I'm going to add 43 to that. We're going to get 175. And we're going to add 43 to that. And we're going to get 218, if I'm not mistaken. Is that right? 218. Yeah. Okay.
Yep.
So now the upper limits, remember, these are the ones that don't overlap. So we have 45 here and 88 here. And then 131 here. Oops. And then 174. And 217. And then we're gonna have to add 43 to that number. So that's going to give us 10, 6, 260. Does that look good?
Mm-hmm.
Okay. How did we get class boundaries from that?
We minus, or sorry, we
Right?
add,
No, we subtract from the lower one
subtract from
and
the
we add
lower.
to the higher one.
Yeah, that's what I meant.
So what is the first class boundary?
2.5.
Mm-hmm. To what?
45.5.
Good. And I know you know how to do that. So go ahead and do that for me. Okay.
Mm-hmm.
How
are you doing, Havana?
Pretty well. Only problem is I have a hard time like distributing the numbers into my pie chart, and it looks kind of weird the way I put it.
Oh, like trying to, yeah,
Yeah,
that
I was
can
trying to portion it correctly. That's
start with the largest percentage, put that in first.
okay.
Start with the largest one and work your way down.
Yes.
217.
Okay. But I know the feeling. that can be, doing it by hand can be, yeah, that happens sometimes.
Yeah, and I tried to use my protractor to like measure my lines, but I don't think I've been doing it correctly.
She doesn't require that you if you do, that's great, but she doesn't require that you do that.
Oh, so she doesn't require it for like it to be like looking.
No, as
Okay.
long as it looks like you actually, she looks at the calculations.
Okay.
But she's, I mean, as long as it looks fairly okay, she doesn't expect you to necessarily use a protractor. So don't stress yourself over that.
Okay.
there are other things that are more important to concern yourself with.
Right.
All righty, so now, how are we doing, Jason?
Just got all the class boundaries,
Okay, now what's the next step?
the frequency. Uh-oh.
Okay,
The
this is where, yeah, this is where we have to
look very closely.
yeah, or put it in your calculator and sort the data. But yeah, this is where you go in and you look to see how many numbers are in each group. Okay.
All right.
Now, what we can do, if you want to skip that and fill out the rest of the midpoints, we can get the midpoints without the data. Okay. The other two columns, I need the frequency, obviously, to get the cumulative frequency, but I can help you. Do you know how to get midpoints?
Midpoints. Let me look at my last assignment. Yes, definitely.
Okay. All right. So tell me how to get the first one.
Okay. And what we're gonna do is we're gonna add the class boundaries and divide them by 2.
Okay. You can actually use the limits or the boundaries, but either way, 2.5 plus 45.5. And we're gonna divide that by 2. So you're doing 2.5, whoops. I'll put it on the side. So midpoints. 2.5
Yes.
plus 45.5.
Mm-hmm.
Divided by 2. It's going to give you, I'm getting 44. So you're getting? I'm sorry, not 44. I lied. 40, let's see, 48. That's 24. Not
Yep.
44. 24, right?
Mm-hmm.
24. So your first midpoint would be 24. Work on the frequencies for that. And then I'll you can continue to stay, but work on that and I will check in and make sure you got it correct, okay?
Okay.
And then we'll start doing the graphing part. 2.2. All right, let me stop sharing temporarily here. And go to the files. Undo. Okay. Data. That's glossary. And here we have okay. What did you get for the first frequency, Jason?
24.
That's the first midpoint.
Oh,
What is the first frequency you should have gotten is, I got 19. Did I miss that? Let me check. Let me see if this is. Let me check this. So I'm gonna share screen here and get, oh, our homework file. Let me get the homework for. So it was between 3 and 45, right? Or 2.5 and 45.5. So let's see. Let's count. So we get here, there, that's 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. The ones that are underlined are the ones that I got for the first 3 to 45, and now 19. Okay.
hold on. Had to rewrite my page because I messed up. So for the midpoints,
Are you doing midpoints or are you counting frequency right now? Because what I just gave you was the frequency for the first,
oh, so this is the frequency?
the first class for the one with 2.5 to 45.5 has 19 elements in there.
It's 20.
It has 19. I underlined them for you on the screen. So this first frequency here is 19. Okay.
Oh, 19. Hello?
I'm here, Jason.
Okay,
So the next thing that I have
46 over 88.
is
46 to
going to
88.
be, let me put them up for you. So this is, let me get the annotations on my screen. There we go. The next class is also 19.
Hmm.
Coincidentally, that doesn't always happen, but it did here. And then we have from 88.5 to 131.5 is 10. There are 10 values there. From 131.5 to 174.5, there are only one of those. I have to bring it up a bit. Then we have 0. And we have 1 here at the bottom. For a total of 50. So that's what your frequencies should look like.
Mhm.
Okay. And I know you know how to get the cumulative. How about the midpoints? Were you able to get that?
Midpoint.
Or have you worked on those yet?
Hold on. Midpoint is. Oh, yeah. So it's 2.5.
Okay, that's the lower. You have the midpoint of the first class. It's 24, right? Because you added 2.5 and 45.5. And got
Yes.
and divided by 2, right?
Yep.
Excuse me, what is the next midpoint after that?
We're 67.
Okay. And then what?
Um 110.
Good.
And then um 110. $153.
Good. Let me just fill this in for you. So this was 110. And then we had, oops. And then we had 153. And after that,
See. 169. 160. No, 196.
almost 196. Okay. And then
290. 239.
239, good job. How about your cumulative frequency?
24.
Be careful, 24 is your midpoint. The frequency is, what's the first frequency you have?
19.
19, right? How am I gonna get the next cumulative frequency underneath?
19 plus 19.
Right, find the frequency column. So we're adding these, right? We're adding this to this now, right?
Yep.
So 19 plus 19 is
38.
38. And then we add 38 plus what?
10.
Good. And that's what?
48
Then the math gets easier. 48 plus 1,
equals 49
49 plus 0,
is still 49.
and 49 plus 1 is
49 plus 1 is 50.
right. Now you have all the data. The good news is you don't have to look at any more data. Okay, you got all the data you could possibly want. You don't have to do any more calculations. You just have to draw graphs. Okay. Now,
Okay.
which columns you use depends on what kind of graph you're drawing.
Oh, the first
Okay.
one is the histogram, which is the class boundary and the frequency.
Right. Very good. Are you able to draw that on your own?
Yeah.
Okay. Go ahead and draw it, and then I'll show you what let me see if they did it right in the book, because sometimes the book doesn't. Oh, they actually did this time. They actually did it correctly.
Miss McKelly,
Yes, ma'am.
for number 5 on homework 2.3, I sorted out my data for both South America and Europe. I know that for constructing the back-to-back leaf, what's it called?
Stem and leaf plot,
Yeah, stem and leaf plot.
right?
We have to prepare the distributions and everything. And I know that we're supposed to put like decimals for all the whole numbers, or like numbers that don't have an extra digit, like the single digit numbers. For numbers like 10, 11, 12, 13, 14, do I put a decimal and a 0 after them and then put them as 0 on the right side?
Let me take a look at it and make sure so that I don't give you wrong information. Let me just take a look first. Because you're working on different sections. Whoops. I don't need well, I may need the PowerPoint, but that wasn't what I meant to open. You said you're working on number 5?
Yep, number 5 for 2.
Number 5, all right. Construct, in hundreds of miles. Okay, actually here. Okay, so these are already in hundreds of miles, right? So you don't have to necessarily use a decimal. You can use groupings like 0 to 9 or 0 to 5 and like 6, because these are already in hundreds. Okay. So you don't necessarily have to, but you sorted all your data already?
Yeah, I sorted it out. I'm just trying to figure out how to plot it on the
Okay, so let me show you this. Maybe it is a good thing I got this out. So here, I think she did an example that was similar. Let me look for it real quick. That's pie charts, that's stem and leaf. She examines 50 down to the nearest dollar. 91 average daily temps for city A and city B. You could actually do something similar to, let me pull it up for you, to this example.
Hold on, I
Mm.
can't see your
No,
screen.
it's coming,
Mm.
but thank you for letting me know. It's similar to this example, which is the third problem. This is the second. This is the temperatures in city A and city B.
Yes.
So you could put the first digit in here, or the stem of that digit in the middle, and then protrude it off the side. So let me show you what this, hold on, I need to stop sharing so I can switch. I've got a lot of screens open. Give me a minute to find your, what was that?
No, with one of the examples, we went from 7 all the way to 10 on
Mhm.
the left side,
Mhm.
and put like everything after the decimal on the right side.
Yeah, so, well, it's a good idea. In this case, though, you have too many like 10s, 20s, and 30s, don't
Yeah.
you? So that's what I was saying. You can make it so it should look something like this. What if you did, let me show you here. So if you were to say, where
It's on
is,
your screen.
no, I know, I'm trying to figure out how to share what I want to share right now. I appreciate the warning though, I really do. So in the middle here, I'm gonna, Jason, I'll come back to this whiteboard in a minute, okay?
Okay.
And we'll look at your graphs and see how they're doing. So here we have, if you want to do this, what I would suggest is that you just split the middle portion. So
Yeah,
you have like 0 here.
Mhm.
So you'll have like 0 here,
Okay.
and then you'll have 1. And if you have too many hundreds, just make this, make 2 stages of this. You know what I mean? Up
Yeah.
through the first 5, and then the next group of digits. And then
Okay.
you'll have like 2 2s down here. So you'll have 2 sets.
Mm.
You know what I mean?
Yeah.
And then you'll have 2 3s. Because let me show you something here. This, I have to stop sharing and share the other screen. This is what, oops, share screen, Shauna. There you go. All right, so here, this is what the book shows us. Let me enlarge, I don't know if you can see that. Let me enlarge it for you. Because that is super small.
I can see.
Can you see that?
Yes, I can.
That's 62%. I'm impressed. All right, so what they did here is 0 1 1 and then 2 2 and then 3 3. So your stem and leaf, what they did was split it apart.
Yeah.
Okay. Make sense?
So I know that. Okay. So I don't have to, for the middle part in the stem and leaf graph, I don't have to put like the 10 and everything
No, you
because
don't need, no, because this is in hundreds anyway. So
okay.
this 0 would be everything from 0 to 100.
Okay.
And then this first 1 would represent 100. So you'd have like 100, 100, 100. You see how South America has a bunch of zeros here?
Yes.
There's a bunch of in hundreds, right?
Oh, and if it wasn't, even if it wasn't 100, like if it wasn't 100, I would just put the regular numbers
Yeah, well, this would
like
be
like
this
10, 11,
this next one would
and
be 15, right? Yeah, they see here's my 11.
yes.
Is that making sense? Are you
Yeah, it is.
digesting?
Yeah, I'm adjusting.
All right, let me see about helping Jason with his histogram.
Okay.
I'll come back. I'll go ahead and leave this up. But I'm gonna go back to section so we can look at the limits that we were looking at before. So you're looking at 2.2, and we were doing so you have, let me make sure that I've got the right, I'm not looking at the right one yet. So we're looking at number 2 on 2.2, which is really this one here. So your histogram, Jason, should look something like this, okay? You have 2.5, 45.5, 88.5, 131.5, 174.5, 217.5, and 260.5. Because your histogram is based on the class boundaries on the horizontal axis, right? And then each of those bars is the frequency tall. So this first bar is 19 units. 19 units tall. So we have 19. Those first two bars are the same height because they both have a frequency of 19. Okay. The third bar is 10 units tall. And then we have a bar with that's 1 unit tall. And then we have a bar, we have a space between 174.5 and 217 because that class didn't have any values in there. Okay. Are you able to see the histogram on the screen? Let me pull it up. We're
Yeah, I
looking
see
at,
it.
okay.
I also have a similar chart
Okay. That's good.
on my screen.
How was the okay, so what would you say about, it says to comment on the shape or the skewness of this distribution, right? So what can you say about the skewed part of this? Which way does the distribution lean?
Which way does it lean?
Well, okay, so when we talk about, and you'll learn more about this in chapter 3, but they introduced it a little bit in this chapter, right? We have bars that are really tall on the left. Okay, that's kind of, think of that as the body of the distribution, right? And then we have these bars that fall off really fast toward the right side. All right. And so we call that the tail. You don't have to remember that word right now, but it's a word that we'll see later. This distribution has a tail or low values on the right side. And so we call this right skewed or positively skewed, because that distribution is pulling off to the right. Those values on the right, they're pulling the rest, you see? This is what happens when you have kind of an easy exam and people get high scores. And so you have a lot of people getting high scores. And then the people who didn't come to class and didn't take the quiz get low scores. That could be one scenario. It's not the scenario here, but that could be one scenario that might be familiar to you where you would see something like that. This is a positively skewed or a right skewed distribution.
I don't get it.
So when we have the shapes of distributions, like I said, we're going to go over this in more detail later. But what happens is we start with something that looks, do you know the word symmetrical? Not sure. Okay. Symmetrical means that one side looks like the other side, like a mirror. Okay.
Oh, which is, does that explain 2.5 and 45.5 having the same frequency?
That's part of it. It's not that doesn't really, the reason those stay the same length is partially because it's symmetrical, but that's not entirely the reason why, but it is related to that. Yes. If you've ever seen those curves, and there's pictures of this in your book, but for example, if I had something like this, here's my distribution, right? There's my distribution there. And I had a bar that was like this. And I had a bar that was like this. If you think of splitting this distribution right down the middle, or doing those activities when you were in elementary school, where you fold it and the left half looks like the right half, this is basically symmetrical. Okay, this left piece looks like this right piece. Okay, they look similar, right? This is a symmetrical distribution. But if you have something that, like we have here, that has really tall bars on the left. So we have a bunch of really tall bars over here. And we have a bunch of really short bars, maybe nothing over here, right? If you get this distribution, if I drew a curve around it, you might have seen this with curves, not values. But if I were to draw a curve, it would look something like this, right? This curve would be pulling, it pulls in the direction of the extremes. So it doesn't, this hump, you can think of the hump as holding it in place. So this hump is trying to hold it in place, and this other piece is trying to pull it over. This is right skewed. Okay, so this distribution would be right skewed. And somebody had a question in the chat. Let me take a look. For Europe, do I place? Yeah, definitely, Giovanna. I'll show you that. Give me a minute to finish up this explanation and I'll show you that. So this distribution would be right skewed. Okay. If I had a situation where, and I think she shows you that, but she doesn't show you that in this. I'm thinking it's not on this set of slides. It might be, it could be, but let me check really quick and see if they're there. No, this is the graphing part. Let me go back to 2.2. Let me check 2.2. Because I think that was the homework. Where are my PowerPoints for that lesson? Homework, histogram. Okay, here we go. Okay, 2.2 histogram. PowerPoint, there it is. Does she show you skew in here? Or not? Yeah, she does. If you look at slide number 18, on 18 and 19, she shows you the shapes of the distributions. Let me put it up for you on the screen here. So this is, oops. Hold on. What did I do? There it is. 2 point, oops. That's not what I want. That's what I wanted. Here are the shapes of the, make sure that I'm sharing screen, which I wasn't, I don't think. Here are the shapes of the distributions. So if you notice, see how on a right skewed or positively skewed distribution, the bars are all sort of taller on the left side? That's what makes it skewed. Right skewed means it's skewed in the direction of where the smallest amount of values are.
Oh,
Okay. This is slide 19. The normal distribution that I was showing you earlier is, they call it bell-shaped. In here, this is a symmetrical distribution. This is a bell-shaped distribution. Okay. That's what we're looking for. So in that question, we're looking for a right skewed answer for the comment, or positively skewed, either way. Okay.
so if it's a right skew, then it's positive?
Right. So right skewed and positively skewed mean the same thing.
Okay.
Okay. We'll you don't have to worry about knowing a lot about skew right now. We're going to get into that more. In the next chapter, we're going to see this distribution, the bell-shaped one. We're going to see that again. When we get into chapter 6, we're going to have a whole chapter on bell-shaped distributions. So
All right.
she's just trying to sort of introduce some of this terminology right now. Let me put up the question that Havana had. Let me stop sharing this and go to the other one. Okay, so you're looking at 2.3, aren't you? Okay, let's go over here. You're looking at the stem and leaf plots. There's more ojibs and it doesn't want to, whoops. Hello, too many, too much. Okay, hold on. Too far. This is, I think this was the, not sure which one this was. Hold on. Oh, this, yeah, I'm way far out. I'm not in the right place. I think we're looking at where am I? Dot font. Here it is. There you go. Yes, Shauna. Havana, sorry.
I'm waiting for
So
it.
South America. Oh, I've lost my screen share. Give me a minute. I think my internet decided to. How about now? Can you see it?
Yep, I can see it.
Okay, so here's your 0, right? And so South America has a 2 there.
Mhm.
And then Europe has 3, 4, 4, 5, 5, 5, 5, 6, 6, 6, 6, 6. Okay.
Where did the 3 and the 4 and all those numbers at the 0 come from?
Okay, let me go back to the homework here.
Because the
So,
homework doesn't list those numbers for me.
maybe, let me check something. Because either she changed it or, but I think, let me check. Actually, this is what happens when you have so many pages open. Let me get the homework out and see where we are. All right, oops, not the right one. My apologies. 2.3.
Mhm.
Okay, actually, you remember that the 10, because you're gonna have a 10 later, right? So
Mhm.
anything that's, because this represents hundreds of miles, right?
Right.
So for example, 39 would be 3,900 miles.
Yeah.
21 would be 2,100 miles. 2 would only be 200 miles.
Mhm.
All the 10s would be 1,000 miles. So all these ones, all these that start with a 1 are going to be under the 1, right?
Right.
But anything that's smaller than 10, you're going to have to put in its own category,
Mhm.
right? So the 2, notice, the 2 is smaller than 10. So you're going to have a 0 and a 2 there. That's going to represent 200 miles, right?
Yeah.
For South America. In Europe, the same thing. This 5 is going to represent 500 miles.
Yeah.
So all of these 5s are going to be less than 1,000 miles. That's why you can't just put 10 and a 0 there. You see?
Mhm. Yes.
So that's where it's coming from the small numbers in Europe. It's
Okay.
coming from the numbers that are smaller than 10 because it has to be back to back and you have to accommodate both. It's coming from that.
Uh-huh.
Does that answer your question?
Yes, it does.
Okay. How are you doing, Jason? So how are you doing with the frequency polygon? Did you get that?
Oh, so I got the I've put for the histogram is a
Mhm.
right skewed.
Right skewed, okay. That's fine.
Do I have to do the same thing for the frequency polygon?
No, you don't comment on the skewness of the frequency polygon, you just draw. You just draw whatever whatever the frequency polygon says. So you just when you do the frequency polygon, the key with that is that your midpoints are on your x-axis and your frequency is on the y-axis.
Okay. And question. The width is 43.
For the histogram and yeah, the width of each bar is 43. That's correct.
All right.
Would you like me to, let me put up the answer again to the for the frequency polygon, so you can see it
Okay.
for the one that you're working on. I think it's this one. Or is it the other? No. No, that's not it. That's the third one. We're looking at
Okay. Just take a picture of the thing.
we're looking at this one here. Aren't we? Yeah, we're looking at this.
I
You
can't
did-
see anything.
Oh, sorry. My apologies.
That's fine.
Let me, I tend to think I'm sharing screen and then I have a rude awakening. Thank you for letting me know, because sometimes I continue on and. All right, so here was your. I think, okay. Yeah, here was your. Not that. Let me back up one more screen. I have to find the page that it was on. So this is the first one
Mm-hmm.
with the, and then the counties, divisions, or parishes is this here. So this was your, I don't know if you need both. I can maybe shrink this so you can get it in.
Oh, I see it.
Here's your distribution. Then here's your histogram. We did that together.
Yep.
Don't forget, they didn't do this in the book, but you'll have to label these points where they come out. So this point here, they're going to be 43 apart. So this is going to end up being 24. This will actually end up being negative. You can put it at 0 if you want, because you don't need to go on the negative side to get another midpoint for that. Okay.
Mm-hmm.
And then here's your, can you see the ogive at the bottom, or do you need me to scroll up some?
That's fine.
Good? You're good?
Yes.
All righty.
May I see the stem and leaf plot for number 5 one more time to make sure I do?
Sure, sure. Are you done taking pictures of this, Jason?
So you said it's gonna be at negative 19?
No, I said, okay, so this midpoint,
Yeah.
your first midpoint was at 24, right?
Yes.
They're 43 units apart, right?
Uh-huh.
So if you want to predict where this midpoint would be, okay,
Mm-hmm.
you have to subtract 43 from 24. This was the first midpoint, but if you do that, you'll end up negative. What is 24 minus 43?
Negative 19.
Negative 19. Instead of making it negative 19, this is something she does that's a little different than the book because it makes more sense than the book. So what
I
we're
just
gonna
minus
do,
43.
instead
I
of
just
calling it negative, just have this be 0.
all right.
That just make that so this is 24, this point right here, right?
Mm-hmm.
That point was 2419. And then instead of just bringing it down to the left of 24, bring it down at 0 here and connect it.
Okay. Do I
Okay.
label it 0 to 0 or is this
You
0 to
could, well,
19?
this would be, no, this would be 0. This midpoint would be 0, wouldn't be negative, okay?
All right.
And this label up here would still be 2419,
Okay.
right?
So just label the first one 0 to 0 or just 0?
0, 0, 0, 0 would be your first midpoint
Okay.
there. So anytime your midpoints come out negative, just go back to the origin.
Mm-hmm.
You don't have to extend the x-axis to do that,
All right.
okay?
Yep.
All right. Is it okay if I move this now, Jason?
Yeah, I have everything.
All righty.
And that's pretty much it.
Okay.
Thank you.
Stick with me for like 2 seconds, Havana, and I'll get your, let me just clear this out.
Okay.
Are you looking for you're looking for the back-to-back stem and leaf?
Yes, I am.
Oh, and
Sure.
another thing, that's all I had. I
That's
know how to
fine.
do the polygon and the ogive. Thank you.
Nice. You're
Have
very
a
welcome.
good night.
Good night, Jason. We'll see you again soon, okay?
Okay.
All righty, let's do this. I think we got a lot of good work done. I think a lot of, probably you and your classmates will get a lot out of watching this if you go back and watch this again. Let's see if or parts of this anyway. Let's see where we are. It's giving me the slow treatment. Let's see if I can speed things up just a bit. If you have the electronic textbook, you have this, but it's just a matter of finding the numbers because she changed some of the numbers on it, but it's, you should still have access to the same, oops. I think I went, did I go too far? Yeah, I did. This is chapter 3, I don't want that. I want chapter 2, this is too far in, okay. So this is our, okay, this is where he was just working. And you're working on the pie chart chapter, so let's see. I should mark that page so I know what page it's on. Here's your seven leaf plot for that. So South America
Mm-hmm.
has a 2
Yes.
with the 0. And we know where that's coming from now.
Right.
Europe with the 0 has a 3,
Mm-hmm.
4, 4, 5, 5, 5, 5,
Mhm.
6, 6, 6, 6, 6. And then with the first group of ones, South America has 0, 0, 0, 0, 0, 0, 1, 2, and 4.
For ones for Europe. Oh, the ones for Europe would be the 1, 2, 3, 4, and then so forth.
Yes.
Okay. And then for the zero would be 3, 4, 5 because 3 is the first digit before the 0.
Yes,
Okay.
because those numbers were less than 100.
Mm-hmm. So anything that if it were, since the problem is focusing on the hundreds in the numbers, if it were 100, the numbers on the right would be less than 100. Is that correct?
So since they're focusing on 100, it depends on which side you're on. So
Oh.
if I'm in South America, right?
Yeah.
Then I always read from the middle, if
Mhm.
that helps you. So the stem here is 1, right?
Yes.
And so this is like a 0, 0, 0, and so forth,
Mhm.
right? Because these are hundreds with a stem of 0, right?
Yes.
And then you have 1, so this is like 110, right?
Mhm.
120 and 140,
Mhm.
right? If I'm reading from Europe, then I'm reading, this is 110,
Yes.
120,
Mhm.
130, and 140. That's how
Yeah.
that works.
Yeah.
If they're smaller than this, then this is 0 and 2. This is 2.
This
right?
would be, that would be 2.0.
You could think, or well, it depends on the key, but having looked at the data, I know that to be true. That's why you have a legend for each one.
Yeah. And that's what I understood, because the examples we worked with were dealing with they weren't dealing with hundreds. So that's
Right.
why when we had 10, we would put a decimal afterwards, and then we wouldn't write a single number in the middle column. We would just put 10 and then the decimal. That's
So if this is less than 100, right? All
Yeah.
of these, not like this Europe is you're reading from the stem. So this is 0, 100, and 3, you see?
Yeah.
But without the legend and without knowing the data, I don't know if this represents 200 or 20.
Uh-huh.
That's why I need the key at the bottom.
Yeah.
Does that answer your question or not?
Yes, it does. That's all the questions I have for today.
All you have for today, huh?
Yep.
All righty. Well, if you could do me a favor, and in a message, pop your, you can use a private message, pop your number in the chat for me.
Okay, my ID number, right?
Your ID, your student ID, so I can give you credit. Because you and Jason deserve a lot of credit for being here for this whole time today.
Thank you so much for the help. I'm sorry if I kept you so long.
No, don't worry about it. Don't worry about it. And if you're interested, we have Professor Nickdell will be in her office. I know you've got like 5 million classes, but Professor Nickdell will be in her office tomorrow from 12 to 1, her Zoom office hours, and I have Zoom just before that. So I have time in the morning tomorrow, but if you guys need extra time or extra help, email me.
Okay. I don't have your email. May I get it, please?
Yeah, definitely. it should be in, you can always email me through the Canvas inbox, but I'll go ahead and put it in the chat as
Okay.
well. You can
Yeah,
email
because
me
I
through,
was looking for it on the syllabus, but I couldn't find it.
okay, so you can, you know how to email me through the Canvas inbox?
I don't think.
Okay, I'll show you that really quick before you go, but let me give you, this is my personal email, which it's not a secret. I gave it out at the orientation as well. So you can email me there. You can also email me at my Cerritos address, which is just my first initial, my last name at cerritos.edu. But let me show you, since you don't know, because that's something you should know in case you ever need help. That it's a good thing to know. And I didn't realize that you didn't know, or I would have said something. So let me show you that really quickly. Do I have the, no, I need to open a tab so I can show you that. Wow. All right. I've got everything else open. All right. So if you look at, okay, let me share the screen. Is this what I wanted? No, it's not. Oh, yes, it is. Yes, it is. Okay. So if you come here, let me close the chat for a second. So if you come here to a page like this, right? On the side, you see you have home syllabus. You see all the blue right
Yeah.
here? And on the other, you see this dark sidebar here. It's
Yes.
blue on some computers. I have it in a high contrast phase. So, so it shows black on your screen, perhaps. But you see under courses, it says inbox. You see here where it says inbox on the side? You can go to your course. Let me put this in student view so it'll look like, student view. So if you go to your course, right, you click on, let's say this is your course here. You'll have the inbox. You can go to the inbox. When you go to the inbox, you'll get a message. It'll pop up. It'll give you a screen to, oh, come on. Oh, it won't let, okay, because this isn't my account, but you'll see a box pop up and you can send us a message. Professor Nickdell or you can send us a message there.
Okay.
From there. Okay.
Okay.
So it's up to you, however you want to do that. You can do it from there as well. Okay.
Okay. Okay. Thank you.
You're welcome. So just hit inbox and then you can, in the to field, just start typing, or you can scroll down and look for her name. You could look for Mojda Nickdell, or you can look for my name and it will populate in the box, just like an email.
Okay. Thank you.
You're welcome.
Good night.
All right, we'll see you later, Shauna.
Okay. See you.
Take care now.
You too.
Sharing.